So in the last video, I talked a little bit about, in general, how an electric race car would kind of look like, some of the requirements and regulations. We also talked a little bit about the inverter. In this episode, it's going to be a little bit more general and a big overview of kind of what's going on. So some of our most important components are going to be these ones right here. So let's just start with so in this race car, we're putting two motors. It could be anything from 80 kilowatts to 250 kilowatts peak power each, depending on what you want. It's going to be, as you can see, rear wheel drive, or depends on if you want this to be the front. So let's just go with the rear wheel drive. We're putting a gearbox on there too, and each motor is probably going to need its own inverter. Next, we're going to put a contactor on there. I'm going to show you a little bit more about contactors. So here we see one of those Panasonic contactors under test, and yeah, you'll fry it. That's what it's kind of for. It's just a mechanical connection to protect your circuits. So it'll close. They put hydrogen inside this chamber to reduce kind of the arcs, kind of keep those controlled. Because every time you make contact, there's going to be an arc flash. Then is the charge port. So it depends on what kind of product you can find and what kind of standard there is out there. But there is a standard charge port you can buy and just fit into the car. Oh, right. And by the way, we're making the assumption that we already have this welded and already had the car body and everything already welded and set up. So all we need to do is just place all of our components. So next, the charge port needs to be connected to a charge module. And what this does is it takes the AC from your plug and converts it into DC. So you can charge the batteries. We got a smart shunt, keeps track of our current. This is going to be important. It's going to be talking to our VCU, tell us how much current's going in, how much current's going out, so forth. We also have a contactor here to protect our circuits in case anything goes wrong. Yeah, and then the charge module goes to the shunt and into the high voltage battery pack. So as you can see, we still have a 12 volt battery in there. This is just to power our VCU and kind of all the electronics that need kind of a VCC running voltage. So we don't need some kind of conversion from the high voltage battery pack. It's a lot easier to just take a 12 volt battery. Yeah, and then we got a cooling pump, mostly for so I'm going to talk a little bit about the battery and how important it is to keep it at a very specific temperature. So let's just listen to, so go to High Performance Academy. These guys are great. They have a great YouTube channel. Here they are at I think they're talking to AEM here, and how important battery temperature is.
As well, long term is going to be key to the reliability of all of those components, I can assume.
Absolutely. Keeping the battery, the battery temperature is key to keeping the battery life. If you maintain the battery temperature right in a sweet spot all the time, that battery is going to be for you, it's going to be there for you all the time. It's going to last years. If you disregard it and you run it hot, you run it cold, you charge it when it's cold, I mean, that's the fastest way to lose 30% of your battery capacity in 6 months.
So you just heard right there how important battery management is, especially the temperature. You want to make sure the batteries, and that's what the VCU is going to help you with as well. It's going to check all the time the temperature of the battery and see how much amp you can push in or out of the battery. So if the temperature is high, the VCU is going to go, okay, we can't push the battery and the motor as much as we want. So we're going to have to, and then the VCU is going to maybe tell the cooling systems to kind of engage and start cooling down the battery to levels that we want. And this all happens fast. You saw the Vc200 runs on 64 megahertz. Depending on how the code is optimized and stuff, it'll check like in microseconds, or milliseconds. You saw those scan pulses, like every 5 milliseconds, every 50 microseconds, there's going to be kind of a control to see what everything's going. The VCU is also very good at doing a pre-diagnostic check. So if anything's wrong, it's going to tell you, so you can't just run the car and abuse it. It's going to let you know, okay, we got some issues here. We shouldn't have a lot of power on this part of the car right now because it's not working properly. So the VCU is crucial, keeping everything in control and keeping everything smooth and organized. So yeah, we got the smart shunt and goes to the high voltage battery pack, and we're also making the assumption that this all fits in the car. And I'm going to talk a little bit about why that is so important. So let's say we have a battery module and it gives us 1.6 kilowatt hours per module. So I usually go by the rule of thumb that 30 kilowatt hours takes you 100 kilometers. So what's that, 60 miles? Probably 80 miles, 120 kilometers, something like that. So this is a rough rule of thumb. You might have to adjust this a little bit depending on what you're working with. So that's gonna require 19 of these modules. So we're gonna have to fit 19 of these somewhere in the car, right? And that's gonna put a lot of weight on different places in the car. We don't want a car that's way too front heavy or way too back heavy. That's why I kind of put it a little bit like this. So we got this heavy component right here, the motor and the gearbox, and I'm kind of counterbalancing that with the battery modules here. So that's a lot of modules. You're gonna have to fit all of this into a car. That's also a issue or a concern that you need to kind of work through and solve. And yeah, maybe the most important part perhaps is the VCU. This thing communicates with your dash, your pedal. So when you're hitting the accelerator, you're hitting the throttle, information is going to go into the VCU and it's going to go, okay, the angle is this much, or, maybe there's a potentiometer, so you get an analog voltage signal. So let's just go on evwest.com, just see what they have. Take a look at what they got. They got Aem Electronics Vc200. So this thing is great. This thing will do everything you need it to do. This thing can control your regen, your throttle response. So you got 13 analog inputs. This is good for your throttle. It's probably going to be an analog input. You got some digital inputs. It's not too heavy, not too big. You can fit this anywhere. Just screw this on. You might need some PDMs, power distribution modules, scattered a little bit here and there to kind of communicate with things throughout the car. So let's just put those. So yeah, and all of that information is going to go through the CAN bus protocol. I can go over that a little bit. Basically, you have two terminating resistors to prevent any reflection on your line, and you have the CAN high line and the CAN low line. So all your devices are going to be communicating with two wires, one on the high, one on the low, and the voltage on the CAN high is 2.5 to 3.5. So it's going to be at a 2.5. When you get a data packet, it's going to be at 3.5 volts. The data packet is a signal might look like this on an oscilloscope. So every specific period of time or so, you're going to get a data packet from something communicating on the CAN bus. So let's say we have a sensor here. It's connected on the high and on the low, and we're communicating with this. This thing is pulling the information. So we're getting these data packets, and if we zoom in on one of these data packets, you're gonna see the bit data it's gonna be a weird signal like this. You're gonna have a 1 and a 0, and this signal might be something like this. I don't know, I'm just making this up. And this is gonna give us a value like 24. So this sensor gives it, what's the temperature? Well, it's 24 degrees C. So let's just say this is 24 in binary. So that's kind of a quick and fast description of the CAN bus line. Yeah, so let's talk a little bit about the battery charging. So you're gonna want to charge your battery, obviously. And there are two stages to charging a battery pack. One is gonna be the CC, constant current stage. And you start with this one, and then you're gonna end with your CV, constant voltage state. So this is gonna show you why a battery charges quickly from 0 or 10% to 80%, and it's the last 80% or so that are the hardest to charge. So if we're on a constant current from our charging module, it's giving us a constant current of, let's say, 100 amps, just to keep it simple. So this is what's going into your battery. So if this is a plot of current over time, so and this is a plot of time and charge. And then, yeah, your charge is just going to go up kind of linearly like this inside of the battery. You can think of that as kind of a well with water. You're kind of just filling this up with constant current. And you're going to reach a point where you're going to have to apply constant voltage. And that's going to top off the last percentages of the battery. And this is why you can see why this takes so long compared to this section right here. Okay, yeah, this is a fast, quick overview. I'm gonna obviously go over a lot of these components in a lot greater detail. For example, just the motor, you can go over that in a lot of detail. If you're an engineer and you're working on a kind of a 3-phase or motor like this, I mean, there's a lot of design considerations. Let's actually draw these copper colors, and then you're putting your winding on these. Because I mean, Tesla just came up with their carbon wrapped rotor, which is completely different. It doesn't have those bridges that kind of absorb flux lines. So I mean, just the design of a motor, you can talk about that for hours or days. So yeah, there's a lot to talk about. Hopefully this gives you a quick little overview of. So I also want to show you EV West, such a great place. EV West is just the best. They got AC motors, complete systems right here, charging stations if you need to buy that. This is great. They got all these little things you'll need. If you haven't already, go check out EV West on YouTube. They show you everything they're doing in their garage, the projects they have going. It's amazing. Yeah, they got all the solutions right here. Here's a charging port, so you can wire everything up right away. I think they're located in the San Diego area, so if you're over there in California, you might want to check out EV West. This is their shop. This is definitely for all your EV projects. If you're going to make a conversion or build a EV race car, you might want to check out EV West.